Okay, on this problem, we're going to find the area between the curves x equals 3 minus y squared and x equals y plus 1. So I've got the first equation graphed here in green, the second one in red. Okay, and you got to watch out for this one because if you try to integrate from where these two things intersect, which are at -1, -2, and what is it, 2, 1? This isn't going to work because you're going to find the area of this part right here. You're going to leave off this out here. So what we need to do on this, since it kind of curves back on itself, we need to, instead of finding the integral with respect to x, we're going to find the integral with respect to y. So we are going to find the integral from -2 to 1, and we're going to use 3 minus y squared minus y plus 1. We're going to kind of, and it's going to be dy. So we're going to look at this kind of sideways. We're going to tilt it this direction. This is going to be up. So we're going to take the green curve and subtract the red curve. And now it's pretty much exactly the same as all the rest. Okay, we use a little algebra here to simplify this a little bit. And we get negative y squared minus y. When we distribute the negative in here, that's going to be plus 2 dy. And now that's easy to integrate. So this is going to be -1/3 y cubed minus 1/2 y squared plus 2y. And we're going to evaluate that from -2 to 1. Go ahead and plug in 1. So that's pretty easy to do. You can almost do that in your head. -1/3 minus 1/2 plus 2 minus, this one might be a little bit harder. So I plug in -2 and I get -8 here times -1/3 is positive 8/3. And -2 squared is 4, and -1/2 of that is -2. And -2 times 2 is -4. Okay, so this right here comes out to be 7/6 minus, this ends up being -10/3. And then that, of course, that's plus a positive. If I put this in sixth, I get 7/6 plus 26, which is 27/6. And that is 9/2 in square units. Or you could put 4.5 if you like.